So in this video we're going to talk about slope, and we're going to discuss the importance in determining change in y versus change in x and how one variable impacts another variable. And so really pay attention to that explanation in this video. So in this video I want to discuss with you slope, and you're very familiar with slope. You've probably been doing it for a long time now. And so what I want to give you is a little bit more insight of maybe some things that you haven't thought about regarding slope and some things that will help you in this calculus course. So what I'm going to do is I'm just going to graph out our coordinate system. Okay, so let's just plot this guy out. And of course we've got your x-axis and we've got your y-axis. Now let's take an actual example, maybe something like some object that's traveling a certain distance from, I don't know, home, for example. So let's say we've got some person on a bicycle, okay, and they're traveling some distance away from home. So let's let x be the time, okay, meaning that when x equals 1, we're 1 hour. Let's do it in hours, okay, so time in hours. And at 2, that's 2 hours, so here's 3 hours, so on and so forth. And then let's let y be the distance that the person on the bike is away from home. So let's do this in miles. So let's say we'll go by tens. So 10 miles, 20 miles, 30 miles, 40 miles, and 50 miles. So they're biking, okay, and they're biking for a certain amount of time, and here's the amount of miles that they've biked. Okay. So let's say we've got 2 points here. Let's say we've got one here. So at 1 hour, they're 10 miles away from home. You know, math doesn't have to be, it's not just about the numbers, it's about looking at relationships. So when we say 110, well, what does 110 mean? That means that at 1 hour, we're 10 miles away from home. And let's say at 3 hours, we are 50 miles away from home, or that person is. Okay. Now, I said that I was going to talk about slope. And what's more important than just getting an actual number is interpreting that value. So when I start to look at the slope of a line, let's take and connect these dots here as best we can. Okay, so here's the line that runs through. I'm pretty close there. It runs through those 2 points. The question is, what's the slope of this white line? Okay, so what is... Okay, so let's go ahead and get that value first. So the slope we call m, and the slope is defined as the change in the y variable divided by the change in the x variable. So what is the change in the y variable? Well, what I'm going to do here is I'm going to, oops, I want to do that a little bit better. I'm going to have to erase this whole thing in the area because it's going to get in the way otherwise. Okay, so let's go ahead. This is best we can here. I know it's a little bit off, but you get the idea. So what I want is the change in the y value. So notice that if I make a little triangle like this purple line, that is equal to, well, that's our change in our x. And the blue line, that's our change in our y variable. So when I go back here to look at this, the change in the y variable is from a height of 10, right? So if you look at this axis, it's from a height of 10 up to a height of 50. So our change is 40. So how do we get the change? We take 50 minus 10, and that gives us 40. Now what is 40 what? Well, 40 miles, right? So our change in our y is 40 miles. So I'm going to just write this down here as 40 miles. Now, our change in our x. How fast does the x change? Well, the x goes from 1 to 3. So we changed by 2 hours. Well, how do we calculate that? It's 3 minus 1. So notice, again, order matters here. We took 50 minus 10. So then we have to go 3 minus 1. Okay, the order does matter. Okay, so that'll give us 2. So that's 2 hours. So what this tells us is during that time period, we traveled 40 miles in 2 hours. Or if we go ahead and we simplify, we traveled 20 miles in 1 hour. Whoops, 1 hour. Or you can think about that as our average speed was 20 miles per hour. That's how fast we biked. So in 1 hour we biked 20 miles, and the next hour we averaged 20 miles. Okay. Now who knows actually what we did in between. Maybe we stopped and we got something to eat, and then we biked really fast, and then we stopped again for a break. Who knows? But the average is 20 miles per 1 hour. So 20 miles in 1 hour. So what's important about slope, slope tells you how quickly, okay, so this is really important. You should write this down. You should have it tattooed somewhere on your arm. Okay, so what does slope tell us? Slope tells us how quickly the y variable, whoops, I want to write a v there. How quickly the y variable changes as the x variable changes. Okay. So what this says is that the y variable, the miles, changed by 20 as the x variable, hours, changed by 1. So the change in the y was 20 as the change in the x was 1. So what we found is a relationship. This is so important. Okay, so calculating slope is not just about computing numbers. It's about looking at relationships between variables. And so our relationship is that the y variable increased by 20 as the x variable increased by 1. Or the y variable increased by 40 as the x variable increased by 2. That's the idea of the slope. It tells us how one variable changes as another one changes. And if you haven't thought about it that way before, start getting used to when you calculate slope, thinking about that change in that y versus the change in the x and interpreting it. Because most of you are going to be taking physics at some point, and in that course it's going to be so vital for you to understand that relationship and not just computing numbers.